Continuing on with our triangles, let's talk about two theorems that we have. The first one is our angle sum theorem, and basically this is just putting into words a theorem something that we already know. And basically our theorem states that the sum of the measures of the angles in a triangle is 180 degrees. We already knew this. We know that the inside of our triangles, each angle, 1, 2, 3, add up to 180. We know this. This is just putting it into words. So each angle A, B, C, A plus B plus C equals 180. So again, we already know this. We're just putting it into, it's an actual theorem in our geometry class. You're going to see some examples that look like this. Instead of having numbers for our angles, it's going to have an equation. And since they all add up to 180, we know that. We knew it before. It's reiterated today. We set them equal to 180. So 5x minus 2 plus 9x plus 3 plus 11x minus 21 equals 180. I first combine like terms, my x's and my numbers, and then I solve for x. And when I do that, I get x equals 8. X equals 8. Now we can plug in our x to each of our equations to solve for the actual measure of each angle. So we've got x equals 8. Whenever I plug in 8 for D, 5 times 8 minus 2, we get 38, 75, and 67. Remember, all three of these angles, when we add them up, they should equal 180. You can check my math here if you don't believe me. Or if I didn't do it wrong. Didn't do it right. Okay, our next theorem is our exterior angle theorem. And an exterior angle is formed when we extend one side of our triangle outside of the triangle. I got my timing wrong. So you can see here we've got this triangle, and the bottom of it is extended, creating that angle 1. And our exterior angle theorem states that an exterior angle is always equal to the sum of the two non-adjacent interior angles. So not the one that's next to it, 2 and 3. So when I add up angle 2 and 3, you see how they are opposite or away from, they're not next to that angle 1. When I add those two up, that will equal angle 1. Okay, so here's an example. We've got our triangle and our extension with our exterior angle. So we can add these two angles inside the triangle and set them equal to that outside equation. So 3x minus 11 plus 4x plus 1 equals 18x minus 15. And I can combine like terms and solve for x. X equals 5. So we've got x equals 5. Now I want to give the measure for each of our angles, all three inside the triangle and then the one outside the triangle. So CAB, remember when we name our angles, we start the middle and then we go down to that B. So that letter in the middle is which angle it's talking about. So CAB, A is that one, 13x minus 11. So when I plug in 5 for x, I get 54 degrees. So ABC that's angle B down at the bottom, plugging in 5 for x. Now ACB, this one it's important to look at. Well, we're looking at C. Where's A and B? That's our triangle. So it's talking about C inside the triangle. So there's no equation there to plug in x, but my theorem before told me that the three angles inside of my triangle add up to 180. So I can take 54 plus 21 and subtract that from 180 to get 105. Now it's asking for DCB. That's DCB. It's C, but this time it's on the outside. So I can plug in my 5, 18 times 5 minus 15. and that gives me 75. I can also, because we know it's a straight line and we have two angles, the ACB and the DCB on the other side, and we know that those two angles have to add up to 180. So I can take 180 minus the 105, and that gives me 75. We also know that angle A and angle B add together to give me that angle C on the outside, so I can add 54 and 21. That gives me 75 as well. There's multiple ways of going about this. There's not one right way of getting that measure. All right, let me know when you have questions.